Now the third part will be short because I know this concept called continuation is pretty new to you. So you may feel uncomfortable, but don't worry. We are going to have 2 more lectures about this. Then, okay. Calling interrupt with a continuation. We implemented the interpreter, right? We implemented the interpreter for an expression E, an environment, and continuation. An expression under this environment, when you are done evaluating this expression, get a value using the value called K. Then what's going to be the K on the top? Meaning in the very beginning, what's going to be K? We know in the very beginning, environment is empty because there is no name with any value. We know that on the top level, expression is going to be the program, the given program, right? Then what's going to be the K in the beginning? How do we start calling interrupt with a continuation? That's the question, right? What do you think? When you are done evaluating a given program under empty environment, right? Under empty environment, you evaluate this expression, you got a value. Using the value, what are you going to do? Return it as it is, because that's the value. That's the value of the program. So in the top level, let's call it run function, which it takes a program, right? Then we are gonna interpret the expression under the empty environment and what? And identity function. Return it as it is. So interpret this expression under the environment, get a value V, using the value call K, right? Call K meaning identity function. Get the value, return it as it is. So identity function is going to be the top level continuation. Okay, yeah, and the value is going to be either num V or closure V, and you can return the result by taking the numbers string representation or just function, because you cannot print a function, right? Okay, this is the first introduction of continuation to you. And this Wednesday and next Monday, we are gonna dive into the continuation passing style by discussing its operational semantics and all that. It's gonna be really cool. So let's sum up. Continuation passing style, it passes work to do as a parameter, as an argument. As you saw before, previously we were like interp E1 plus interp E2. Meaning what? After evaluating this E1, we had to come back to this point, actually this point, to interpret this E2. And we need to come back to this point to do addition. Meaning this interp of E1 plus E2 calls interp of E1. It comes back. It calls interp of E2. It calls back, right? It comes back to the caller. But by using continuation passing style, it does not have to come back. No need to return to callers. Does it make sense now? In the beginning, it may not have been clear, but now it should be clear that no need to return to callers. So it does not need to remember where to come and what's the value of E1, things like that. So it's good for time and memory performance. For E1 plus E2, the first thing to evaluate is E1, so the redux is E1, and the remaining thing is continuation. And the remaining continuation is get the value of E1 and then do computation of E2 and addition using this value. That's the continuation. And after evaluating E1 to N1, the redux is now E2. And the continuation is get the value of E2 and do the remaining work. And finally, after evaluating E2 to N2, the continuation is to return N1 plus N2. Right? Yeah, it's that simple. So we have material about continuations as usual. You can read these articles. I recommend you to read them before diving into the continuations for the remaining 2 lectures.